So here on this page, we're going to look at the back side of the 5.3 notes. And this back page is going to cover 3 new types of factoring that we're going to explore that go beyond what happened in Chapter 4. And I'm also going to highlight for us how to identify these compared to the other types, because that's an important step to recognize what type of problem you're working with so that you can take the correct solution steps. So all these here, these are called sum and difference of cubes. And what you'll notice is they all have 2 pieces. Okay? And more specifically, they have an x cubed as the leading degree. Now these can easily be confused for stuff from Chapter 4 that would also be 2 terms, but it might be x squared minus 25. That's a different type. That's factoring sum and difference of squares. You'll be able to recognize these when you see 2 terms. All right, and the first one is an x cubed, and then the second one is just some type of number. And it could be addition or subtraction. So that's how you recognize these 2 terms where the highest exponent is 3. Now, what these formulas are here, they look intimidating. But I'm going to go ahead and highlight some of the things that are shared between these 2. And when we look at it from this perspective, we realize that it's not really memorizing 2 formulas because everything highlighted is the same between the 2. The only things that are different is that they differ between a little bit of addition and subtraction on a couple of them. Okay? And once you do several of these become pretty easy. Some people like setting these up even better than some of the other factoring types because they don't take a lot of critical thinking. Stuff that you will have to memorize is this order of a, b, a squared, a, b, b squared, which follows a nice rhythm. And especially after you do it a few times, you'll definitely get used to it. The a, b, a squared, a, b, b squared. And then we have a nice little acronym that's going to help us remember how to address the different signs. Because you might remember, dang, how am I going to remember that one goes positive, negative, positive, all that stuff. An acronym that we have for that, it's very easy to use, is SOAP. Right? It's going to stand for same, opposite, always positive. All right, and that's what's going to help you remember what signs to use on this. All right, and here's what I mean by that. If your initial problem started off with a plus sign, your signs would be the same, so a plus sign, opposite, which would be a negative sign, and then always positive. This one here starts negative, so it would be the same, opposite, always positive. So if you can remember SOAP, and you can remember AB, A squared, AB, B squared, which just follows a little pattern there, you're good to go on these. All right? Now, when we're given these problems, they're going to come in a cubed form. As you can see here, there's a cubed, b cubed. So in order for us to actually use these formulas, we'll have to track down what regular a and what regular b is. All right, and it's not hard to do. All we'll have to do is cube root the x term, all right, which will give us regular a, and you have to cube root the number term, which will give you b. Okay, so let's take a look at this first example. Well, my x term is x cubed. If I take the cube root of x cubed, I'm just going to get an a, because cube root and x cubed cancel out. So a here is equal to x. All right, and then if I cube root the 8. Now, this is really the only instance I can think of to where we ignore these signs. These signs are going to be encompassed by SOAP, so you don't have to worry about whether this is a negative 8 or anything like that. We just want the cube root of 8. And that's asking what number multiplied by itself 3 times gives us 8. And that is a 2 in this case, because 2 times 2 times 2 gives us 8. All right, and then here's the setup. And once you do some of these, they become not a big deal at all. Let's start off with our signs. I see I've got a negative sign. So I'm going to go same, opposite, always positive. and then I will place in my a, b values. And the formula goes a, b, a squared, ab, so in this case 2x, and then b squared, and 2 squared is 4. So that is the factored form of that. All right, and if you don't believe it, I'm going to distribute it out here real quick, which you don't have to write this part down or kind of understand this, but it's just a little proof that this does in fact factor out. Now, if I distribute these x's, all right, we'll get these terms. I'm just doing these 3 lines right there. We'll get an x cubed plus a 2x squared plus 4x. Okay, and then if I pair it up with coming from this way, I get a negative 2x squared, a subtract 4x, and a minus 8. And you see that all these terms cancel out, all these terms cancel out, which takes us back to our original expression. So there's the proof that it does in fact factor out based upon our factors. And it doesn't take a lot of critical thinking. I mean, you just use the formula. You use your cube root style method to find a and b, and then you set up into the formula. So that's the good news, is you don't have to think very critically to do these. However, if you don't know the formula, I do not give you very good odds on factoring this on your own, because it's very tricky to figure out how to get everything to cancel out in the right way. So let's take a look at this one. Very similar concept. We're going to need a cube root to find a and b. So cube root of 27x cubed. Well, cube root of 27 is 3, because 3 times 3 times 3 gives me 27. Cube root of x cubed is just x. To find my b value, I need the cube root of 1. Okay, so there's my a and b values. And then we just get our parentheses set up here. So we've got this. We're going to use SOAP. I started off with a plus sign, so it's going to be the same, then opposite, then always positive, and then we do our formula, which after you do this several times, you can remember it, no problem. It goes a, b, a squared, so 3x squared would be 9x squared, ab, which is 3x times 1, plus b squared, where 1 squared is 1. And there we go. That is, once again, the factored answer. So when you get really good at these, you could do these probably faster than any of the other type. Now, one thing I want to mention, the setup on these isn't that bad to do the AB squared, all that stuff. However, these are not particularly fun to solve. This one isn't asking us to solve because we're not equal to anything. However, if you are asked to solve these, all right, so when solving these type, I want to make a special note here. The first piece, which is the smaller of the two, it's very easy to solve. Right? You'll always just be able to set it equal to 0, right? And then you can find x. Right? So like both of the ones that we've done up here above, this particular piece here would be very easy to solve. It'd just be x is equal to 2. This one right here, I could set that up equal to 0, subtract the 1 and divide by 3 to get that x is equal to negative 1/3. The bad news on these, though, is that the second piece, which is the larger piece, will always be imaginary. You're always going to get an imaginary answer. So with that being said, you're going to need the quadratic formula. Now, feel free, if the opportunity arises, to use completing the square. A lot of the times you can't complete the square with it, though, because it'll have a number out in front. And when it has an a value that's not 1, completing the square is not worth your time. The first example, though, this is actually a good candidate for completing the square if you knew how to do it. But just keep that in mind. When you're solving these, that second piece will 100% of the time be imaginary. So you're going to have to use quadratic formula. That second piece will never factor. So you shouldn't spend any time trying to do that. Nor would you need to graph it, because it's not going to cross the x-axis ever, that second piece. Okay? All right, so I encourage you now to try this one out. on your own. I'm going to pause the video, and then when you push play, so you can pause the video, and when you push play, the answer will kind of show up there, and then we'll move on to the next set. All right, so here would be the answer for that one if you wanted to double check your progress, see if you made any mistakes or messed up on anything. All right, so we're going to skip that fourth one and move on to factoring by grouping. All right, so the first thing we're going to need to identify on this is what makes something factoring by grouping. How can I tell? These look very distinct from the other ones. These are probably the easiest ones to identify, and that is because there are 4 terms. And if you look back at any of the ones on your 5-3 notes, they either had 3 terms or 2 terms, but never 4. Factoring by grouping is guaranteed to give itself away by its 4-term appearance there. Okay. Now, to do factoring by grouping, it's a little different. Also doesn't take a lot of critical thinking. Here's the way it works. When there's 4 terms, we have to group them up into 2 sets of 2. And what we'll do is we'll use greatest common factors on both of those pieces, and then check this process out. The greatest common factor of that red piece will be x squared, leaving us left over with an x plus 2. The green piece, you always want, and this is just a general math rule, you always want your leading term to be positive. So I'm going to need to take out a negative to make that right there positive. So this would be a negative 3 is the GCF for that, leaving us left over with an x plus 2. Now, you know you're on the right track on completing the square, and then later on in the chapter you know that completing a square is working correctly when these pieces match. All right, if those pieces match, that means completing the square is going to work. All right, to write the answer, and this part trips people up sometimes. It's a little different, but it's not hard once you practice it some. The first piece are the 2 GCFs that you pulled out, so x squared subtract 3. The second piece is whatever piece showed up twice. What confuses people, though, is they often ask, why doesn't it get a squared right here? Right? Why isn't there a square there? Because I see that factoring piece twice. Well, if you look carefully back at the original equation, or the original piece that we factored, there is a subtraction sign separating these 2 pieces. So they will never meet through multiplication. And if they never meet through multiplication, this can never become to the second power. So people who don't really pay that close of attention like to put the second power there because they're trained to see the same factor twice to make that so. But these will never actually multiply. They'll always be separated with an addition or a subtraction sign. Okay?